If oil was the blood of the 20th century, microchips are the brain of the 21st. Without them, your car is a metal box. Your phone is a brick. Your military is blind. We are not talking about a niche tech problem. Almost all of the world's most advanced chips are made in one place, one island, the size of Maryland. This is the Microchip War, the invisible conflict reshaping the global order. No bullets required, just silicon. In the 20th century, nations built entire foreign policies around securing oil. They formed alliances for it. They destabilized governments for it. Sound familiar? Semiconductors are now inside every smartphone, every car, every missile system, every AI server, and every modern weapons platform on Earth. Every single one. The global chip market is worth over $600 billion annually. But without chips, the $100 trillion global economy simply stops. The 2021 chip shortage gave the world its first preview. A shortage of chips worth $1 each caused automakers to halt production of $30,000 vehicles. The industry lost over $200 billion. That was a minor shortage, a temporary hiccup. Now imagine a complete cutoff. That is the scenario keeping defense ministers awake at 3 a.m. across the entire Western world. To understand this crisis, you need to know about a Dutch company most people have never heard of. It may be the single most strategically important corporation on Earth. ASML makes the machines that make the machines that make the chips. They produce extreme ultraviolet lithography machines, EUV machines, and they are the only company on Earth that can make them. One EUV machine contains over 100,000 components. It weighs 180 tons. It costs $200 million. It requires a Boeing 747 just to transport. It is the most complex machine humanity has ever built. ASML ships roughly 50 machines per year. The waiting list is years long. Every advanced chip manufacturer on Earth depends entirely on ASML's production schedule. If ASML stops, the chip industry stops. China cannot access EUV machines. The US pressured the Netherlands to block exports in 2023. This single export control is considered the most significant technology restriction in modern history. Now meet TSMC, Taiwan's semiconductor manufacturing company, founded in 1987. It may be the most consequential company ever built, and most people still cannot name it. TSMC manufactures approximately 90% of the world's most advanced semiconductors. Not Taiwan's chips, the entire world's most advanced chips, from one island, in one strait. Apple, Nvidia, AMD, and Qualcomm all design their chips. Then they send those designs to TSMC to actually manufacture them. The entire tech industry depends on one factory complex on a disputed island. TSMC's most advanced chips are made at 3 nanometers. A human hair is 70,000 nanometers wide. TSMC etches circuits 23,000 times thinner than a human hair. This is not manufacturing. It is applied physics at the edge of what is physically possible. If Taiwan's chip production was disrupted for 6 months, analysts broadly agree the global economy would face a recession more severe than 2008. The word most commonly used in these assessments is catastrophic. Washington has decided that allowing China to develop advanced chip capability is an unacceptable strategic risk. The result is the most aggressive technology export policy since the Cold War. The CHIPS Act of 2022 committed $52 billion to rebuilding American semiconductor manufacturing. 2 goals: reduce Taiwan dependency and slow China's progress. 1 very large check. The US also coordinated with Japan, the Netherlands, and South Korea to restrict chip equipment exports. a full-spectrum technology blockade covering machines, designs, and design software. China responded by committing over $150 billion to domestic semiconductor development, the largest state investment in a single technology sector in recorded history. Target self-sufficiency by 2030. China cannot yet make cutting-edge chips, but it dominates legacy chips, older semiconductors used in cars, appliances, and industrial equipment. Legacy chips represent about 70% of actual global demand. China also controls roughly 60% of global rare earth mineral production, the raw materials needed to make chips and chip-making equipment. Cut off our chips. We control your ingredients. Now for the scenario every government has modeled privately, but none wants to discuss publicly. A conflict in the Taiwan Strait. TSMC has confirmed that in the event of a military invasion, its factories would be rendered inoperable. The technology would not fall into hostile hands intact. The world's chip supply would stop immediately. The downstream effects would cascade fast. Automotive production halts, electronics manufacturing freezes, military equipment production slows. The modern world, stripped of its silicon nervous system, begins failing in sequence. This is why Taiwan's chip industry is called the Silicon Shield. The theory: Taiwan is so essential to global supply that any military action would be economically devastating, even for the aggressor. Mutual dependency as deterrence. Whether that theory holds depends on whether all actors remain rational under pressure. History's verdict on that particular assumption is, at best, mixed. Here is the central paradox. Globalization created the most efficient chip supply chain in history. It also created the most dangerous single point of failure in economic history. Efficiency and resilience, it turns out, are enemies. We built a $100 trillion economy on a foundation thinner than a human hair. One island, one company, one strait, one miscalculation away from a cascade nobody is fully prepared for. The US is rebuilding domestic chip capacity, but TSMC warns that replicating 35 years of manufacturing expertise takes decades, not years. A government check, however large, cannot buy institutional knowledge overnight. China is investing massively to catch up. But without EUV machines, Beijing is running a technology race without access to the most advanced equipment. The gap is narrowing. It is not yet closed. Meanwhile, global chip demand keeps rising in AI, in electric vehicles, in smart infrastructure, in defense systems. Supply concentration has not changed. Demand is growing. The fragility is deepening. The question is not whether the world depends on silicon. It does. The question is whether we can diversify that dependency before something forces the answer upon us. Can the world survive without the silicon shield?